Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quad University of Science and Technology. Today we will take lecture number 16 of the subject of Object-Oriented Analysis and Design, in which we are going to discuss modeling the activity diagram in the UML. Dear students, this is very much important topics because the activity diagram represents the behavior system of the project. That means that activity diagram represents different activities when a user will perform these activities to interact with the system, and these activities can be represented in the form of a unified modeling language diagrammatical representation. So that is very much important topics. Also because you will use this activity diagrams to create different other diagrams in your final year project as well. So that's why understanding of this topic is very much important. This is the discussion agenda. It contains first of all the activity diagram definitions. Here we will explain what is the activity diagram. Then we have that when to use the activity diagrams. Also we have the components of the activity diagram examples. Here we will provide you different examples of the activity diagram. Now we have the business flow or the business activity diagrams, which represent the process here, and the process is of the order systems example. Also we have the swim lanes and object flow activity diagrams. And then we have some expansion regions, which is in fact a region where the activity diagram will be expanded. And at the end we have the disadvantages of the activity diagrams. So these are the key topics that we will cover in this lecture. Now, activity diagram is a diagrammatical representation which has certain activities. As its name indicates, the activity diagram describes different activities, and these activities are in fact represents the workflow behavior of the system. The workflow behavior of the system means that how the system will behave with the end users and what is the workflow of their tasks which will be provided to the end users. And all these activities are provided in a sequence, so that's why this represents the workflow behavior of the system. Now, activity diagrams is used in a process modeling. Means that when we want to model a certain process, then we can use the activity diagram to represent that particular software process. And also used to analyze the requirement engineering process. Means that when we develop the activity diagram of our projects, so all these diagrams represents the requirement definitions of the systems, that how these requirements will be obtained and how these requirements will be documented. So activity diagram represents diagrammatical representation of the software requirement specification, which is very much important document in software development. The activity diagram provides a business process flow, which is usually synchronized with the several different external incoming events, and these are represented with the help of the activity diagrams. The business process represents certain process where different activities will be performed, and these activities are synchronized with each other, means that they are properly in a format or in a sequence where different external incoming events, means that these different inputs to the systems will be represented by the activity diagrams. And here each activity will perform certain functions. These are used for understanding the workflow analysis, synchronous behavior across a process. That means that activity diagram represents certain techniques which is useful for understanding of different sequence of actions which will be performed, and these actions are synchronous, and these actions represent certain behavior of the system. So these activity diagrams can be represented as a form of a process here. Activity diagrams are mostly used for documenting the existing process. As you studied in software engineering, different existing processes of software development like waterfall model, like spiral models, like prototyping models, and others software development models. So all these software development models can be represented with the help of the activity diagrams, and each activity represents certain phases of the software development. But here we will represent the activity diagram for programming concepts, means that different operation performed by a software and the user interacting with the different components of the software will be represented with the help of the activity diagrams. Also, activity diagrams is used to analyze new process concepts. Means that when we want to analyze the process concepts, that what are different components of the process and how they perform certain actions or events, then the activity diagrams is used to provide the analysis of that particular process, and that process can be in fact represented in the form of the activity diagrams, which can be purified later on by the expert peoples. Also, activity diagram is used to finding re-engineering opportunities. Re-engineering means redevelopment. So, when we want to develop the same system with the help of some new technology, that is called re-engineering. That means that sometimes we require advanced tools to develop the existing systems, because existing system was developed in the previous technologies, which are now superseded with the advanced technologies. So that's why finding the re-engineering opportunity is very much best for them. So hence activity diagrams will be much useful to represent that particular product with the new technology. And then with the new technology we develop the new activity diagram, so that will be in fact a refined activity diagram as compared to the previous activity diagrams. Also, activity diagram is used to describe the state of activities with the help of the sequence of activities performed. So different state of activities are defined by the activity diagrams here. The state of activities means that currently the activities is in the pending states, or it may be in the execution states. Also, we can say that that particular activity may be in the form of the waiting states or so on. Some activities can be conditional or parallel. Conditional activities are those activities which depend on certain condition. If that condition is satisfied, then the activities or the set of activities will be performed. And if that condition is not satisfied, then the other activities or set of activities will be executed. Or it can be parallel. Parallel means all these activities are performed in a parallel sequence. Means that at once all these activities performed in one particular unit of times. So these are called the parallel activities. So can be either conditional or parallel. Now activity diagram has a certain events and activities. Events and activities are almost two same things. Activity represents certain actions, while events also represent certain actions. And but when the event rises, certain activities may also be executed. For example, hitting a button on a keyboard is an event, but login is an activity. So when we press OK buttons, then the login activity will be performed. So pressing the OK buttons or clicking the OK button is in effect the event here. And that is in fact when the activity is executed, there may be one or more events that may trigger the other activities or the process. So one activity can execute one or other activities or full other process, which will be the part of this project. So activities is in fact starts with the symbols and end with the finishing symbols here as well. So there is in fact start symbol and finishing symbol of the activities, which are different components of the activity diagrams. We will cover the components of the activity diagram in our upcoming slides. So activity diagrams represent certain decision, attrition and parallel random behavior of the process as well. The decisions are those symbols which decides that whether this set of activities or an activity will be executed or not. Iteration represents the looping. So when the iteration is executed, that means number of times that particular activities are executed, and sometimes parallel or random activities may be executed. The parallel activities are executed at once. All activities are executed in 1 unit of time, while the random activities are picked up by the computer randomly. Means that the computer picks some activities or skip another activities. So there is a random selection of that particular activities. Now, activity diagram capture action performed. So all actions are performed using the activity diagram. Also, they stress on what's performed in operations or methods. When the function is executed or the method is called, so then the activity is performed here. So activity diagram also represents certain operations or methods. There are certain cases where we can use the activity diagrams. So activity diagrams can be used when we want to model the workflow behind the system which is being to be developed. So when we want to develop a certain system, we need to model the software system. So when we require the model of the system, then we will use the activity diagram. Activity diagram is very much useful for analyzing the use cases, which is used to define the action need to take place and when they should occur. That particular action will be called. So when we want to analyze the use case, and the use case contains multiple sort of the actions which will be in fact called or executed. So that's why analyzing the use case by activity diagram is very much useful. Also, activity diagram is used to describe the complicated sequential diagrams. Sequential diagram is sometimes become very much complicated. So just to make it a little bit simple, so that's why we will convert activity diagram, sequential diagram into activity diagrams so that sequential diagrams complexity may be minimized. Activity diagram is also used to model application with parallel processes. Sometimes we call parallel programming. So parallel programming is that programming also called concurrent programming where different actions are executed in the concurrent fashions. Because the parallel programming saves the times and resources and also it speed up the processing. So that's why it is very much important to represent the certain problems of the system through the parallel programming. Activity diagrams do not provide us the detailed way of how the objects behave or how the objects collaborate with each other. Because activity diagram is very much abstract, so that's why the activity diagram doesn't provide us a complete overview about the object interactions and object collaborations. Now we will discuss different components which are required to create or design the activity diagrams. So first component is called start or initials node. This is a filled circle which is used to represent the starting point or the initial state of the activities. Every activity diagram starts with this filled circle. The second important component is called activity. The activity diagram represents the ongoing or interruptible execution of the certain events which will be called here. And this represents the workflow of the operation or transaction. Usually, the activity represents certain tasks which will be performed. So it is represented with the rounded rectangles. And the text contains inside of this rounded rectangle represents an activity. For example, login is one of the activities, so that's why here we will write login. Similarly, searching or insertion or deletions are different activities, so all these will be literally written inside of this activity. The third components of the activity diagram is called control flow, also called the edge. The edge is used to represent the flow of controls from one action to another action. For example, here we will perform, right, create the one action, and second, here we will create another action, and here we will provide certain labels which represents the flow of the actions. The decisions is in fact used to define that computers will take certain decisions that whether an activity or group of activity will be performed or it will be skipped. So decision may be shown with certain labels inside of this diamond symbols. So by labeling multiple output transaction activity with different guard conditions are provided here. So here the stereotype is required, which is used for the decision, and traditional diamond shape is used for one or more in incoming arrows towards this diamond symbols, and one or more arrows can go out of this diamond symbol by labeling their actions. So the distinct guard condition with no event trigger is used when you want that there is not certain events is required here. Another component used for the activity diagram is called fork, and the fork represents that a flow that may be branched into multiple or parallel activities in the activity diagrams. So, for example, this is incoming actions are, and then when this action will be executed, so multiple other actions will be executed. So each multiple activities or actions are defined here with this ending symbol of the arrow line head. So arrowhead connects certain actions which are executed in parallel. And also we have the joint components in the activity diagram, which is used to represent the two or more than two different inputs which are merged into one output. So for example, username, passwords are two different inputs, and when that these inputs goes to the login page, then the login will be performed. So two or more than two inputs are merged into each other to create one output. And next component is the sending signal component, which is used to represent the actions of the sending signal to an accepting activities. So when the sending signal is sent to a certain activities which accept the sending signals, so that sending signals is represented with this symbols, and inside of this symbol we provide a signals which is used for sending to certain activities. Similarly, the receiving signals is signal recipients, which is used to represent that the signal is received to the activity. So that is the receiving signals. Also, we have certain note or comments which is used to add a relevant comment to the elements or another elements in the activity diagrams. So inside of this comment symbol, we provide certain comments here. And also we have the final node, which is used to mark the end of all control flow within the activity diagrams, and this final node represents that the activity diagrams is completed and there is no certain events or actions beside this final nodes here. Now this is the example of the activity diagrams, and it is used to process the order through the activity diagram. This activity diagram is used to represent the order receiving and processing system. First, it is the start symbol of the activity diagrams. From here, the activity diagram is started, and this is the activity, which means certain actions. So first receive orders is in fact activated, and after receiving the order from the customers, then we have the fork, because there are two different another activities will be executed in parallel after receiving the orders. So fill orders and send invoice. So these two actions will be performed in parallel. Also, after these two actions, we have another two operation in parallels. But first operation here is the condition or branch. So If the rush order is accepted, means that the order is in fact here the rush orders, so then the overnight delivery will be performed. Means that if it is urgent order, so then the overnight delivery will be performed. And if it is not the rush order, means urgent order, then the else action will be performed and regular delivery will be performed here. So all these are combined here, I'll merge here, and after merging, so then the close order will be performed, and here is the join symbols of the activity diagram, which joins all these two actions, and means that these inputs are joined here. And if the order is received, then the invoice will also be sent. Invoice contains the receipt that will be sent to the customers, and received payments will be action will be performed here. So means that after fulfilling and sending the invoice is sent to the customer, then the payment will be received from the customers, and then the order will be closed here. After closing the orders, the activity diagram will exit. So that means that this is the end states of the activity diagram, and it is the final states of the activity diagram here. This is also the same example almost, but here the activity diagram is in fact provided or represented from left to right, not from top to bottom. So it is portrayed from left to right positions. While in the previous example, here we have provided or represented the activity diagram from top to bottom fashion, but here it is from left to right fashion. So when you draw the activity diagram in different tools, so then you have to provide the pen of the activity diagrams. So inside of this pen you will provide the stereotypes of the process order. So means that here the process order is the activity diagram name, and that is literally written here. So from just this label we will understand that what is the purpose of this activity diagram, or what this activity diagram is showing here. So process order means that this activity diagram will process orders. So first request order means that after starting the activity diagram, the input will be provided to the receive order from the request order inputs. So this is the activity or the actions, so which receives the orders from the requested order. After receiving orders, we have conditional statements here. So if the order is rejected, for example, if there is no insufficient balance in the customer's credit card, so then straightforward the order may be rejected, and then the close order activity will be called, and then activity diagram will also be closed. But if the order is accepted from the customers, then fill order means that the order will be filled here. Here the customer will fill a form that contains different sort of the information like customer name, customer address, etc. So then there is the join operations here, so that's why we have the join, and then send invoice and ship the order will be called here. So means that two operations will be performed in parallels. So invoice will be sent. Here is the invoice. You can see that there is the difference between this symbol and this. This is a rounded rectangle, while this is the solid straight line rectangle. So this represents certain activities send invoice, and here represent invoice. That means it represents certain action which has already taken. So this is the invoice, not send invoice. So this is the activity which will be performed here. Then we have the ship orders. So order will be shifted. In fact, to ship, the order will be shipped to the customers, and accept payments. Payments will be accepted by the company from the customers. And here is also another join. And when this join is in fact transferred to a single inputs, so here is, you can see that here is just condition, but condition is empty. So then the order will be closed here. So that means that here nothing will be performed. But here you can see that order may be either rejected or accepted. So this is true false condition, but here is not certain action. So that's why here just the order will be merged. Means that these two operations will be merged and close orders will be called. This is the activity of the close order, and at the end the activity diagram will be exited. So means that this is the completion of this activity diagram. The activity diagram can also be represented with the help of the swim lines. In the swim lines, we have two or more than two swim lines, and these swim lines represents that multiple activities will be performed here for a certain components. For example, here is the customer components, here is the sales component, here is the warehouse components of the project. So when these components will be executed, this set of the activity will be executed, and when this component will be called or executed, so here you can see that only two activities will be executed. In the warehouse, we have this set of activities or actions will be executed. So means that the swim lines arrange different activities with respect to their components here. So for example, first we have the customers. Customers here provide the request for the orders, and then the sale components will be executed. So here the order will be processed in the sale components, and in the warehouse components we will search for the orders. So because all the components, all the products will be in fact placed in the warehouse or in the database. So here order in the progress. So here that means that order is in the progress, and all orders are in fact here placed in that particular object flow. And then the pull materials means that from the warehouse the particular orders which are the material which is requested by the customer will be pulled, and then the order will be shipped to the customers according to his or her address. Then here you can see that two parallel activities will be performed. So this is the merging of the activities. So here the order will be filled and customer bill will be provided to the customers. So bill customers means that bill will be provided to the customers. Here when the bill is provided, so that means that here B bill unpaid. If the bill is unpaid, so that means that the order will be closed. So if the bill is paid, so then the order will be processed. So it is the object flow. This is also another object flow, means that these are not actions or activities. These are two different objects. This is also the objects because order is an object, not field order or some order processes like the activities, but just order is the object. Receive orders, then the order will be received from the customers. So after then the activity diagram will be exited. In the activity diagrams we have the expansion regions. The expansion regions contains the expansions of multiple operations are on the collections, and these operations can be performed individual elements of the collections, which is in fact provided with the same diagrams without the need to show that all of the details, but straightforward iteration has been performed here. So for examples here, if we receive one or more than one order, so we do not provide another diagram, so the same diagrams is used here, but this different sort of the boxes represent certain expansion regions. So here it means that one or more orders can be received. So this is the expansion regions. So it represents that the orders value is the input to the expansion region. So here each execution of the expansion regions works on one or more elements of the order collections. Similarly here you can see that one or more products will be processed here, and similarly one or more money for the orders which are in fact different cost of the orders. So these are computed here. So this is the money, means that 1, 2, 3 and so on. But usually we have provides 4 boxes, but that represents 1 or more. So expansion region represents that different orders are expanded here. So like here you can see that 1 or more orders are received. Similarly, 1 or more cost will be computed in the form of the money, and also 1 or more products will be shipped. So shipment will be performed for 1 or more orders. So this is called the expansion region. This is another example of the activity diagram. It is the ATM system diagram. First we starts the activities from the customer modules, then inserts the card. This will be performed by the customers. Again, the PIN code will also be entered by the customers. So after the entering the PIN code, the bank module will be called. So here the authorization will be performed, or it will check that whether the card is valid or invalid. So here if the PIN code is valid, then execution will again go to the customer's module. If it is invalid, so then the reject card will be ejected. So eject card and take card and end will be performed here. But if the PIN code is valid, then enter the amounts to withdraw from the ATM, then check account balance. If the account balance is in fact less than amount which is entered by the customers, then again the show balance can be executed, means that the show balance will be executed that your balance is less than, and then eject card will be performed. And if the balance is greater than equal to the amount so which is required to withdraw, then the fourth will be performed here, means that here will be joining. Then debit account will be debited for that particular amounts, and also the take money slots will be executed, means that the money will be dispensed to the slots, and take money from the slots message will be displayed on the screen. And here it is the joining, and then show balance, means that at the end the balance will be showed that after deducting that particular amount from the total amount, so then the net amount will be shown here, and then eject card will be performed, means that the card will be ejected back to the customers and the customer will take the card. So this is another example of the activity diagram of the ATM machine. Here is another example. So this examples provide you that order management system. It is the same, but here you can see that this is the activity diagram which is very much rough, and there's you can see that two different terminations. That can also be possible that you can define two different termination, but it is better to define just one termination. So one termination can be just here by using that fork here, and only one terminating symbols will be defined here. So this is just the same example of the order management system, but here I have mentioned that here are two different terminations, so you can convert that termination to one just terminations here. Also you can see that there is no certain sequence, because it should be either from the left to right or from top button, but here you can see that the execution will be performed in this sequence, that first, then here, and here you can see that here is the merge. So after here, then the termination symbol will be called, and from after the confirming the orders, then they dispatch the order, and then termination symbol will be called. So this is not for not in the fashion of top to bottom or from left to right, but this is the combination of both. So I prefer that you should use either from top to bottom fashions of drawing the activity diagram, or from left to right fashion. So you should select one of the both. But this is some mixed representation of the activity diagram. Activity diagrams also have certain disadvantages. And the main disadvantage of the activity diagram is this one, that activity diagrams do not explicitly present which objects execute which activities. Means that here we cannot specify which object is going to execute the activities. In another way, the activity diagrams is not collaborating with the programming of the system. So here we just provide certain simple activities, and each activity contains different labels which specify the actions which will be performed here. And also there are messages of the activities that different activities collaborates with each other, but we do not provide certain objects which are in fact responsible to call these activities. Now, for this purpose, we can perform the labeling of each activity with responsible objects that can be done. So these are two different solutions of that above problems, that we specify certain labels for that particular objects which are responsible to execute that particular activities. Also, it is much useful to draw the activity diagrams early in the modeling of process, which helps to understand the overall process. So we have to draw the activity diagrams in the early development of the project. So early stages of the development of the project is very much useful, because at that time we have no sufficient idea that which objects are useful here. So just the activity diagram is that particular stage of the software development which provides us only the idea about the process which will be used to develop that particular project. And that activity diagram will help us to understand the overall process of the project. Then the interaction diagrams can be used to help you to allocate different activities to the classes. The interaction diagrams, we have multiple classes, and each class has certain activities, so we can use the interaction diagrams to allocate different activities to the classes here. Dear students, this is the end of the lecture and class. So these are two different books you should read, and these books are very much important to gain complete idea about the topics. So also we have provided the idea about the activity diagrams, and these concepts are taken from the UML and Object-Oriented Designs Foundations books. Another book is Object-Oriented Programming and Java. So you can get the programming concepts of the UML from this book. So these two books are very much important for you, and you should study these books. Still, if you have any question, you can ask this question through the email. My email is n.kalim@kust.edu.pk. I will wait for your questions and will respond to you soon. Thank you very much.